Unit 5, Chemical Formulas. What does chemical nomenclature mean? Chemical nomenclature is a system of naming. Remember ions? Ions are atoms that have a different number of electrons, resulting in either a positive or negative charge. Metals are named the same as the element plus the word ion, so sodium ion. Nonmetals are named with the "ide" ending, so nitride ion or chloride ion. What is a binary ionic compound? Binary ionic compounds consist of only two elements. We name them by naming the metal, the cation, first, and then the nonmetal. So, for example, sodium chloride. So if we look at this one, we named the metal first, potassium, and then fluoride. Then we have magnesium, the nonmetal, bromide. Try the last one on your own. What is the crisscross rule? So to write a formula, write the two ions separately, showing their charges. Hint, use the periodic table to determine the charges. Then swap the two numbers and drop the sign. You don't need to write the number if it's a 1. So calcium sulfate. So calcium, Ca, and sulfate, SO4. Calcium has +2, sulfate is -2. So since they're the same, we don't have to crisscross them. It would be 1 and 1. Barium. So barium, the symbol is Ba, and nitrate is NO3. Barium has a 2+, and nitrate is only a 1. So we're going to crisscross them. So whenever we crisscross, if we have a polyatomic ion, we want to make sure to put it in parentheses. If it's a 1, we don't have to write it. So that would be the formula for barium nitrate. And we have aluminum hydroxide. Aluminum is a 3+, hydroxide is a 1-. So we're going to crisscross again. So our formula would be aluminum hydroxide, and then 3. So what do you do if there's a transition metal that doesn't follow the rules? In the transition metals, some elements can have more than one possible charge. If the metal is in groups 3 through 12, you may need to use Roman numerals to denote the charge. So we're going to look at our crisscross rule. If we have cobalt and it has a 2 here for chlorine, chlorine is a -1, that means that cobalt would have to be a +2. So this would be cobalt 2 chloride. So fluorine is a -1. That means that mercury would have to be a -1. Then we have iron 3 and N2. So nitride is a 3-. Iron would have to be a 2+ for those to be the same. So this would be iron 2 nitride. So these tell you, when it's written in Roman numerals, that tells you the charge. So iron has a +2 charge. Oxygen has a -2 charge. So that would be our formula. Okay, mercury has a +2. Oxygen has a -2. So our formula would be HgO. And nickel 2, chloride has a -1. So we would have NiCl2. What are oxyanions? Oxyanions are polyatomic ions that have a nonmetal bonded to one or more oxygen atoms. To name oxyanions, identify the ion with the greatest number of oxygen. This ion will have the 8 ending. The ion with the second number will have an "ite" ending. These are ions that you are going to need to memorize. So look at the polyatomic ions on the very first sheet of this packet. Naming covalent compounds. Remember that covalent compounds are compounds with only nonmetals. So the first step for naming a covalent compound, make sure that the elements in the compounds are all nonmetals. The name of the first symbol goes first. Step 3, name the second symbol using the root name followed by oxide. Then look at the number of each type of atom. The number will tell you which prefix to use. Remember, if there is only one of the first element, you do not need to write mono. So the prefixes that we need to know, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So look at the names on the quick check. So we have phosphorus, and there are 4 of them. So we have 4 phosphorus, that would be tetra, phosphorus. We have 5 sulfurs, so 5 is penta, and then sulfide. So we use the ide ending. Okay, look at the next one. We have 1 carbon, so carbon. We have 2 di, and it's an S again, so sulfide. Okay, the next one, we have 2 nitrogens, so di, nitrogen. Now we have 4. And whenever you're using oxygen, you can leave off the A, so tetroxide. Okay, now look at the other ones going the other direction. So you have phosphorus. Tri tells us that there are 3, and we have chloride, so Cl3. So we have sulfur and oxygen, and we have 2 oxygen, so sulfur dioxide. Now we have boron, there are 2, and hydride, so hydrogen, and tetra tells us that there are 4. So naming acids. Binary acids contain only hydrogen and 1 other element. So to name these, you'll use the prefix hydro, and then the stem of the second element with the suffix ic, and then add the word acid. So this would be hydrofluoric acid. This one is hydro. It's chlorine, so chloric acid, hydrochloric acid. What are polyatomic acids? Polyatomic acids are acids that contain a polyatomic ion and hydrogen. There are 3 or more elements in the acid. So look at the polyatomic. If the ion suffix is ate, you change it to ic. If the ion is ite, you change it to us. If the ion has 2 oxygens fewer than the ate ending, you add hypo and the us ending. If you have an ion that has more oxygen than the ate ion, add per and the ic ending. The perchlorate ion would be perchloric acid. Then you add the word acid. So this is a carbon 8 ion. So if it's an 8, you change it to ic. So we would have carbonic acid. This one is not polyatomic. This is just a binary acid, so it would be hydrobromic acid. This ion is the sulfate ion, and so it would be 8 changes to ic, sulfuric acid. Okay, carbonic acid. We have the hydrogen and our carbonate ion. Carbonate is a 2, hydrogen is a 1, so H2CO3.